exponentials and using logarithms and such. So I'm going to look right here. We're going to go to example 2. And we've got 5x equals 8. So when we have a situation like this where we don't know the exponent, the best thing to do is take a log of each side. So when we do a log of each side, we have to use whatever the base is as my base for my log. So log base 5 to the 5x equals log base 5 of 8. Okay. So once we've involved logs, now we have to look at rules for logs. What's the first thing we can do? We can get rid of this x by using, what is that rule again? We don't call them exponents all the time. We sometimes call them, starts with a P, power. So we're going to use the power rule. So we move x to the front. Log base 5 of 5 equals log base 5 of 8. Now, log base 5 of 5, what does that equal, guys? You guys remember? It equals 1. So we can just have x equals log base 5 of 8. Now, our calculators will probably be in test to press mode when we take our test or our exam or on an SAT. So we have to use the change of base formula when we use this. Yes, ma'am? It'd still be 1, yeah. Now, when I say it's in test to press, that means it will only do log base 10. It won't do anything else. So we have to do change of base. So that means we get log base 10 of 5, and I'm not going to put the 10 because I know if it's just a log, I know it's base 10, divided by log of 8. And then this is where I put it in my calculator. And I'm going to get x equals 0.7739. That's my answer. It definitely matters. You have to use whatever your base is to go on the top. Just like when we learned change of base. So you can go back to those notes if you're having difficulty. Okay. Next, we've got E. Now, E is a different animal. Okay, so we can't take like, you know, over here we took the log base 5 because my base here was 5. Well, my base here is E. Do you guys know what kind of log we take if the base is E? Anybody have another guess? Natural log. So if you guys looked at Khan Academy this weekend, you probably heard some about the natural log. The natural log just helps us, it's like the opposite or the inverse of E. So the first thing I see here, too, is I've got another exponent. So I'm going to use that power rule again. And I get negative x natural log of E equals the natural log of 5. What's nice about the natural log of E is if you plug it into your calculator, you'll see that it gives you 1. So I just get negative x equals the natural log of 5. What else could I get rid of with this? What's in front of my x? Negative, so I'm just going to divide by negative 1. So I get x equals negative natural log of 5. Stick that in my calculator. X equals negative 1.6094. Okay, I would like you guys to try C on your own after we do one step. So I'm going to pause here for a second because I think I'm going a little fast for some of you.
How do you plug in natural log of E?
Okay, so if you take your calculator, if you look right next to the log or 10 to the x, there's e to the x. And if you push the blue button and then put ln, or natural log, and then don't push the blue button but put e to the x, you're going to put it to the first power. Right? Because if you just have an e by itself, it's just e to the first. And then if you press enter, you will get 1. Okay? For C, the first step I want you guys to do before you try this on your own is we're going to subtract 1 from each side. Don't forget to do that. 2x to the 4th. Now this is set up just like A, so I want you to solve it and show all your steps like that, and then I'm going to call on some of you guys to try it out. You guys ready, or you need another second? All right, anybody ready and want to give it a try? Go ahead. Mm-hmm.
Okay, so from there you go, log base 2 x equals log base 2 to 4.
Mm-hmm.
And then you do the power rule, so it'd be x log base 2 of 2
Mm-hmm.
equals log base 2 of 4.
Okay.
And then since log base 2 of 2 equals 1, you just do x equals log base 2 of 4.
Yep.
And then you would do x equals log of 2 over log of 4. And you get x equals 0.5 or 1/2.
Perfect. That was wonderful. All right. Any questions about this one before we move on to the back? Yes, Ethan?
That's not what I got.
What did you get?
I got x equals 2.
You probably put log of 4 over log of 2 instead of the other way around.
But 2 squared equals 4 and 4 plus 1.
Yeah. You're right. Okay, let's go back to our change of base notes and make sure that Miss Murphy told you to do the right thing. Okay. Change of base. Oh, that's why, guys. This is incorrect. This should be 4 over 2, which gives us 2. Which means this one right here is wrong as well. So this should be log of 8 over 5. So that's really important to make sure we look at those. So let's change that log of 8 divided by log of 5. Gives us, this is not correct, this should be 1.29203. Can you come back in 10 minutes? Thank you. Okay. Any questions about that? You guys see how I messed up the change of base? Should be the log of A over log of B. Okay? All right. Let's turn it over and look at the back, and maybe we can reinforce that a little bit. Except we won't be because these are all changed base 10. Okay. What is my, let's do F, and then I want you guys to try the rest on your own. So what is my first step with F? What do I need to do first? Even before that. Even before that.
Multiply by 2.
Multiply both sides by 2. This side by 2, and this side by 2 to get rid of that 1/2 in front.
Oh, okay.
So that gives you e to the negative 2x equals 12. And then I can do the natural log both sides. See how I just wrote it in so I had less writing to do? Just try to make it simpler. I'm going to do the power rule, which is just going to give me 2 to the x, correct? Because the natural log of e is just 1. So I'm going to leave that part off too. You can, of course, show all those steps, guys. I'm just showing you the quicker way to write it.
Thank you.
Then I'm going to divide both sides by negative 2. And I put it in my calculator, and I get x equals negative 1.2425.
So you would do inverse 12 divided by 2.
This is not inverse. This is natural log of 12 divided by negative 2. But yes, you just stick that in the calculator. Correct. Okay, do D and E. So first you need to get rid of that. So you need to subtract 1 from both sides. Then divide by negative 4. And then you take the log of both sides. You guys ready?
Yeah.
Good. All right. What's the first step for D that we should take? Add 6. Perfect. So we get 10 to the 2x equals 152. What do we do next? Then we can take the log of base 10 to 10 to the 2x equals the log of base 10 to 152. We know log base 10 of 10 gives us 1, and we can use the power rule to give us 2x equals log base 10 of 152. And how do we get rid of that 2? Divide by 2. And we don't need to do any change of base because it's already log base 10. So we're just going to get x equals, yeah, we'll just keep it as 1.09. Okay. E. What's my first step? Minus 9, good. So negative 4 e to the x equals negative 4. What's my next step? Before then. Divide by negative 4. E to the x equals 1. So I'm going to take the natural log of both sides. And I get x equals, natural log of 1 is 0. Because the natural log of e is 1, so the natural log of 1 could not also be 1. Okay, we have 2 word problems to do that use logs, and then we will be done. Okay? All right, I'm going to zoom out a little bit so we can see the whole problem here. Okay. You deposit $2,000 into an account that pays 2% annual interest, compounded quarterly. How long will it take for the balance to reach $2,500? So we're going to say it equals $2,500. And we're going to take 2,000 times, plus, 0.02, because that's the interest, compounded how often? Quarterly. And we're going to raise that to the number of years divided by how many times it's compounded, so 4. Everybody okay with that equation? I think coming up with that equation might be the hardest part.
It's not 1.02.
No. It's 2,500 equals 2,000 plus 0.02 over 4 taken to the t over 4. Okay?
Yep.
So, now we're going to take the log of both sides. Log of 2,500, and we're going to take log base 10. And log of 2,000 plus 0.02 over 4 to the t over 4. Okay? So our first step is we're going to do the power rule to get the 2 over 4 in the front. So log 2,500 equals t to the 4th log 2,000 plus 0.02 over 4. We okay so far?
So why did you put the t over 4 first?
Because that's the power rule, right? This is an exponent up here. So when I take the log, I want to do that power rule and move it to the front. That's the whole point of doing the logs in the first place, because that's the only way to figure out what the exponent is, okay? So now I'm going to do log 2,500 and put it in my calculator. And I get 3.39794 equals t to the 4th. And I'm going to put log of 2,000 plus 0.02 over 4 in my calculator. And I get times 3.30103. Okay, so all I'm doing is putting it in my calculator right now. Okay, next I'm going to divide both sides by 3.30103. I'm getting rid of this right here, next to the t to the 4th. And I'm going to get 1.02936 equals t to the 4th. And what do I do to get t by itself? Yes, times by 4. Okay, so I get t equals 4.11743 years. And of course you can round. next one, luckily it gives us the equation almost completed. Since 1972, the U.S. Fish and Wildlife Service have kept a list of endangered species in the United States from the years 1972 to 1998. The number of species S on the list can be modeled by S equals 119.6 e to the 0.917 t, where t is the number of years since 1972. In what year did the number of endangered species reach 1,000? So we plug in 1,000 for S equals 119.6 e to the 0.0917 t. Now, what am I going to do first to solve this problem, to get t by itself? Divide. Get rid of this stuff in front of the e. Okay, so I get 8.3612 equals e to the 0.0917 t. Now I'm going to do what? Natural log. Natural log of 8.3612 equals the natural log of e to the 0.0917t. Okay, I'm going to get 2.1236 equals 0.917t. 36. Here, I'll zoom in a little bit. Sorry, Abby. And my last step, I'm going to divide by 0.0917. And I get t equals 23.1582 years. So that would be the year 1995.16, so in a couple months. Any questions on that before we get started on our homework? So then I took 23.1582 and added it to 1972, because that's the year we started. So I took this many years and added it to 1972, because that was the number of years we started. Yes? 0.166.
So whenever it was the natural logarithm,
Yeah.
e to the 0.0917t.
Yeah.
How come it stays up?
So the natural log of e is what?
How did that just go away?
So what's the natural log of e? 1. The power rule brings that whole exponent thing to the front, the 0.917t. So we could have 0.0917t natural log to the e right here,
That would just be
but that's just a 1. Yeah. Okay. All right, guys. Your homework is on the board, page 520, 12 through 19, 24 through 27, and 32 through 39.